What are you up to today, Yusuf? What's going on, my dude? I hope you're doing good, my friend. Let me turn this down a smidge. That should... Oh, not like... It wasn't like this, Yusuf. It wasn't like this. Alright, there we go. Think that'll work? Oh, well, it's kind of dark. Hang on a second, my friend. One light change, everything, my... Alright, there we go. All good to go. How you doing, Yusuf? I hope you're doing good, my man. Hopefully things are pretty chill. Hopefully you're doing absolutely fantastic. Just chilling, ready to learn some maths? Excellent! That's what I like to hear. You're willing to learn a little bit of maths. I'm willing to learn to teach you a little bit. I don't got a problem with that. It'll be pretty, hopefully today will be pretty easy in all honesty. So I think it'll be pretty relatively straightforward. You're looking forward to this slate of weekend games, I'm sure. Got the men's game in a couple of days. I forgot when the women are playing, but I would like to watch those on some live broadcasts if possible. So, we get that going. That wouldn't be so bad. It's going to be a nice, exciting weekend watching a little bit of football. Today is NFL football, American football. Today is the first day of NFL football. Thursday night. Thursday night is the Buccaneers and the Cowboys doing battle. First game of the season. Pretty exciting. I ain't gonna lie. Gonna be pretty exciting. Tonight at 7:20. There you go. Right after my last class there. There you are. Be watching that game tonight. Alright, we're gonna get started here in just a few minutes. Start with some new material. Work our way up from there. See how far we get. We're making our way there. Making our way there. The only thing I struggle in math is borrowing numbers. Are you talking about like subtraction and are you talking like in terms of subtraction? In terms of subtraction, excuse me. Trying to say it, Adam. Trying to say it in terms of coming out of my mouth. It's really hard for some reason. All right, you want me to show you a quick example? I can be more than happy to show you a quick example. Go to the big board, my man. All right. Now, there's a couple things you have to consider about when you're borrowing numbers if you're trying to do it by hand, Yusuf. All right, so let's take one here that's pretty simple, at least to start with. Let's do something simple, and then we'll do a more complicated example. So let's say you're taking like 312 minus 157. Okay. So this one's a little bit easier. It's not too bad. Now all you gotta do here, Yusuf, is you just gotta see about the two numbers that are given to you here. So again, you start from the right, okay, Yusuf? So you're like, okay, well 2 is not as big as 7. So you're gonna have a problem here if you're trying to subtract straight up. So what you need to do is to borrow 10 from the next column over. You need to borrow 10 from the next column over. You're going to make this 12, okay? So that's the first thing you're going to do. Just make this 12 right off the gate. All right? Now, if you borrow 1, you're going to change this 1. You're going to change this down to 0. Okay, and we'll come back to this here in a second, okay, Yusuf? But again, just take it one step at a time. Now, if you do 12 minus 7 here, Yusuf, you're going to get 5. So that's fine. 5 is going to be part of your final result, no problem. Now, I'm going to show you what happens after that where things can get a little confusing. What happens if you borrow from the next column over, but you have to borrow again? You take a look at 0 and 5, and 0 is less than 5. So you're like, okay, well, 0 is less than 5, so what do I do? Well, I need to borrow, once again, from the next column over to the left. So if I run into the same situation, well then, I borrow from this 3 and I change that to a 2. I still take this as a 10, because I'm borrowing 10. Hey, good afternoon, Hisa. I take 10 minus 5, and that's going to be 5. Okay. And then finally, I can take 2 minus 1. That's a straight up guy. And then there we go. We have it. We have 155, just like so. You're just going to repeat that process as many times as you can in order until you get to a point where you're not borrowing from the next column over. Now the same thing works with zeros. So this is a relatively straightforward example, but let's say it's a bunch of zeros instead. Let's say it was like, let's go with 400 minus 135. Okay. Let's say this is the one we're using here. Well, I'll show you how this works. Well, again, we would have to borrow 10 here from the next column over. So I would make this 10. Now, if I'm going to borrow 1 from the next column over here, Yusuf, now I have a 0 here, so how do I borrow 10 from the next column over? Well, there's a little bit of a rule here in this instance. I would change this to a 9. Okay, basically it's like you're cycling back. So you have 0 to 9, and if you go backwards from 0, you end up right back at 9 again if you're taking like a big old wheel. But if you get a 9 here, you also have to borrow. If you're borrowing from a 0 here and you're going cycling back to a 9, the rule goes for borrowing is that you have to also borrow from the next column over to adjust for that borrowing. So here you have 10 minus 5, which is 5, 9 minus 3, which is 6, and 3 minus 1, which is 2. And so here you're going to get 265. Hey, it's Gemma. How we doing? Hope we're doing outstanding. So 265 is what we get here at the end of the day. Do you have any questions about that? Hopefully that made some sense there. And I just want to make things as easy as possible. That was my picture of my old. Yeah, I did. Because I put those promotional spam banners. Somebody spams, I will ban them. So, yeah. Just playing on your Xbox at the moment? Very good, very good. What game are you playing, Gemma? Or are you playing Apex? Or I don't know what you're playing. Did that make sense, Yusuf? Here we go. Alright. Get those basics down. Very important to get those borrowing basics down. Alright. COD Warzone, very good. Nice. Alright. Now try and apply those to your practice problems there, Yusuf, and then seeing if you can apply, again, these same rules based on my explanation, and hopefully borrowing will be just a little bit easier to do. If you have questions, Yusuf, just ask again, okay? And I'll be more than happy to do some more examples for you. Me too. I'm complete rubbish too. Don't worry, you're not the only one. All right. Let's get started here, ladies and gentlemen. Let's go to the big board here. Let's go to the big board. Oh my God. Okay. All right. Let's go to the big board. Let's go ahead and do some intros here. And let's get started here. Okay, let's get started today. Welcome back to Thursday. End of the week time today. Today we're going to pick up where we left off last time in Chapter 3 for a portion of... Didn't talk about proportional logic, but if you have a question about proportional logic, I'll be more than happy to help you out with that, Athena. We have so today we're going to pick up where we left off last time. Last time we did stuff with a data set. We talked about the sample standard distribution, talked about population standard deviation, excuse me. Population standard deviation, sample standard deviation, we looked at variance as well, so we saw that how that would work here in a given data set here. Today, we're going to be now arranging the data or taking a look at the data in a slightly different way here and putting it into a what we call a box plot. Okay, so we'll be talking about that and just a little bit more. Just stopping by, gotta finish. Hey, you asked me if you need some homework help after. So if you want to come on by there, Athena, again, you say, hey, I need some help with this homework. Feel free to ask. It's not a problem. All right. Okay. You know I'm here for you. All right. So, no problem. What I'm here to do. All right. Now, let's go ahead and take a look here at the big board. So let's look at the big board here today. We're going to take a look at several questions. We ended off, now, if you have the notes there, we're going to do this question right here, which talks about how do we find the z-score. Now, I'm going to actually point out one thing here. I technically do have notes here for 3.3, but for this class here, for Math 102, just as a side note here for you guys, we are skipping section 3.3. Okay, so you won't have 3.3 on your homework. We are skipping section 3.3. For this course, we are. So, again, you should not see any homework associated with that section. I checked yesterday, and I was like, okay, just making sure that I didn't have that for you guys. So, there'll be no homework, no questions related to it, nothing on the test related to it. Okay, everything from section 3.3 is just now scrubbed and gone. So, that's for my 120 class as opposed to our class here. So, like I said, anything we don't cover here will not be reflected on the test. However, where are we starting here? We're going to be starting here with the last two sections here of Chapter 3, which is 3.4 and 3.5. Those are the last two sections that we do need to be doing here, at least in this case. Now, in order for us to get started here, let's take a look at question 3 here, right on screen. The question 3 says, how do we find the z-score? Now, we're going to talk about this concept of z-score here quite a bit. Because it does come up in a lot of different other concepts that we'll see here later on. So, again, the book kind of talks about the idea of z-score, kind of relates it to something, but we'll see kind of where that relationship is really going to bear fruit in other sections further forward. All right, but let's talk about what z-score is as a definition. Z-score as a definition is the number of standard deviations a data item is away from the mean. So, we look at it and say, hey, if we're given a mean and standard deviation, and we look at one particular data item, we can make a determination based on this formula here for z-score about how many standard deviations it's going to be away from the mean with that given information. So as you see here, the formula would be, the z-score would be equal to the data item minus the mean and divided by the standard deviation. I did put a couple of notes here and the notation, so we'll talk about that. So first and foremost, it's okay to get a negative z-score. Okay, that means that that data item is to the left of the mean, for example. Okay, so it's less than the actual number that the mean is would be. The notation here would be z is equal to, or z of the data item. I'll show you that in an example here in just a moment. And because if every data item is unique, then that means that every data item has its own unique z-score. So every single z-score is going to be unique, given the fact that we have different data items for each one of those z-scores. If we have the same data item, yeah, we're going to get the same z-score. But Only in that instant. You're probably saying, well, let's use the definition we have here. All right, so let's use this definition we have here. And let's use it in an example. All right. And yep. All right. So let's say for this example here for number 3, let's say we're given a mean and standard deviation. So let's say the mean here is going to be 25, and let's say the standard deviation. Let's say the standard deviation is 6. Okay, so let's just go with that. Just two random numbers I just randomly chose. Doesn't have any meaning to it right now. All right, now if I want to find the z-score here, let's say I've tried the z-score here of a particular data item. Let's call the data item let's say 12. Okay, so I find the z-score of 12. All right, nothing too fancy going on here. It is what it is. So I'm going to take the data item, which is 12, subtract it by the mean, which is 25, and divide it by the standard deviation here, which is 6. And again, if you have your calculator out with you, can anybody give me an answer here? 12 minus 25 divided by 6. Anybody got an answer for me here? Go out to go out to a few decimal places, that's fine. Minus 2.16. Okay, is that what other people got? Minus 2.16? Okay, minus 2.167, okay. All right, so I'll use that, that's fine. So minus 2.167. Okay, good. 7.8? No, definitely not. I know how you got 7.8, Hisa. You just entered it in as is. See, the calculator is very particular, Hisa. You can't do it like that because it'll do division before it does subtraction. So if you're going to do it properly there, Hisa, you got to put 12 minus 25 in parentheses and then divide it by 6. Otherwise, the calculator is going to spit out bad answers. That's why I've made the warning here. The calculator is very particular about how it wants things entered. So you need to, you can't, like I said, with the calculator, you can't half-ass it. It's like, it's unfortunate, but the calculator is a very particular piece of machinery. So hence why I'm giving the heads up. All right, so minus 2.167. All right, that's perfectly fine. All right, and that's your final answer. Now, again, that comes down to the fact that, again, you could have a negative z-score here. You can have a negative z-score here, and that's not a problem. All right, so you can have a z-score here. That's not a problem. That's negative. That's perfectly acceptable. That's perfectly fine. All right, let's try another one here. Let's try z of, I don't know, 32. All right, so z of 32, plug in 32 minus 25. Sure. I just made it up. So where did I get the 12? Guys, I just made it up. That's just our example. That's just our sample. That's just our data item. I randomly chose a data item of 12. There's no rhyme or reason why I specifically chose 12. It was just for the purposes of the example. As you can see in the next example, I just chose 32. Like, I literally just chose a number, and I'm just checking its respective z-score, okay? I swear there's nothing else to it other than that. Hopefully everybody's okay with that. All right, so 1.167, good, good. All right, good stuff. Very good. All right, so you can see we get a positive 1, we get a negative 1, That's perfectly fine. Again, each individual data item is going to have its own unique z-score. It is what it is. Yeah, Lena, I'm not gonna. Yeah, I just randomly came up with the numbers. I promise you. Okay, Lena. All right. Okay. So the real question is, okay, we randomly come up with how many standard deviations these particular data items are. So I would say, for example, to go back to our examples here, I would say the data item of 12 is negative 2.167 standard deviations away from the mean. Or again, 32 is 1.167 standard deviations away from the mean. All right, in a sense, that's how you can basically verbalize what those actually mean. However, there's one more thing that we want to do with this, and probably the more important thing besides just using the standard definition of a z-score, and that is we want to be able to quantify these z-scores and see what kind of relationship it has in the overall aspect of the actual data set. Now, in order for us to do that here, what we want to talk about next is we want to talk about percentile. That's what number 4 is talking about here. I think I should need to make this bigger here. That's right, Connor, my man. It's been a hot minute. How you been? Hope you're doing good. So what does percentile mean? So percentile means is that the data item is k% better than all the other data items in the data set. So we're going to talk about percentiles here, is that the data item is k% better than all other data items in the data set. Man, it's been a while, I ain't gonna lie. It's been a very long, hot minute. Alright, so here's what I'm going to do. I'm going to go ahead and put up a poll for you guys. Let's put up a poll. Alright. Alright, so I'm going to put up a small little poll here. And this is in regards to testing, okay? So maybe like actual testing for... I'll put this up here. So if you can tell me, what kind of test have you taken in the past? I've been great. Have you taken the ACT, SAT? Have you taken both types of tests, or have you taken neither test? Okay, I just want to get a good poll about what kind of testing people have done in the past for college. You know, again, ACT is more of a, you know, Midwest sort of thing. SAT is more of East Coast, but again, college to college, it just depends what they allow. Some people take both, some people do one or the other. So I've just put in all 4 options. Some people haven't done either, so I'm just putting all the options on the table. I just want to see exactly a breakdown of people based on what they've actually done for their academics. So, a very simple question. And again, just you know, I mean, I'll just answer for myself. At least I can tell you that I only took the ACT, but back then the ACT was primarily just for Midwestern schools. I don't think that's the case anymore. Yeah, what's the story with ACT SAT? I don't know if you guys can fill me in because it's been many years. It's been 2 decades. So up and say hi. Gotta help Calvin write for Song for a Challenge. All right. Take care, Connor. Have a good one, mate. Yeah, like for me, I only took one because only one was really required. I don't know. Is it true that more schools, ACT is majority for Chicago public schools? But is it true for like universities and stuff, Angie, or anyone else who wants to answer? That is it true? Is just ACT, or are more schools taking both as an acceptable kind of entry, you know, to get admission and stuff in the Midwest? I don't know what's going on with that because testing standards change. Wow, 4s across the board for ACT, SAT, and both. Most schools prep for only one. Okay, it's very interesting. So if I applied to U of I again, but if I tried to get admitted into U of I today, would they take both or would they just take one of them? Because I mean, the society has changed in terms of what. I haven't seen the school prep for both. Okay. Yeah, that is pretty detrimental. I think that's a very solid point there, Angie. More schools are interchangeable with what they accept. Huh. Okay. That's very different than what it was back then. Like I can tell you, like when I graduated high school in '97, it was either one or both, one or the other, but not both. Like Roosevelt accepts either. Okay, that's fair. That's fair to say. So it looks like it's pretty even across the board. Some people have taken just the SAT, some people have just taken the ACT, and some people have done both. And more power to you if to take both. So okay. Now I'm sure for those of you who've done both or just done one of the two, I'm sure that you probably get something in the mail or you get something emailed to you, regardless of whatever the case is. And they give you a breakdown of your score, right? So they go through the 4 categories and they say, let's say it's the ACT, for example. They say, oh, well, since it's out of 36, you got like a 30, and you got a 29, and you got a 28, and you got a 27 on these sections, whatever the case may be. But as also to go along with those scores is they talk about the percentile there. And that's where we want to kind of hone in on. On those score reports, they talk about the percentiles here, meaning to say, let's say I did really good on the math portion. Let's say I got a 30 or whatever on the math portion. And let's say that put me in the 90th percentile, just as a random number here. Well, what that means is that would mean that I did better than 90% of the people who took that same exact test. Okay? If I'm in the 90th percentile. Okay? If I did extremely well, maybe I'm in the 99th percentile. That means I did better than 99% of people who took that same exact test. Okay? So in a sense, how it works in statistics is works in the same vein, where it's like, okay, that data item is going to be bigger than, say, X percentage of the other data items in the data set. Okay, and so that's essentially how we want to kind of view it, much the same way you would view a grade report on the ACT or SAT. Now, full disclosure here, because you guys are cool. All right, I could tell you what I got in my ACT because I took it 2 times. So I took it the first time I took the ACT, I got a 22, and then I did a prep course for it, Kaplan. And then I took a second time, I got 3 points better, I got a 25. And I was like, okay, that's fine. So I like 25, I'm cool with this. And then it got me into U of I. I'm like, okay, that's fine, 25, no problem. Yeah, I don't know what you guys got, but that's what I can tell you what I got. I never did take the SAT, so it would have been interesting if I did take the SAT back then. Heck, if I take it today, it'll probably be just as tough, in all honesty. All right. Are there any questions about percentile and how pretty much that works? We're going to be looking at it in the same exact vein as you would, like, say, SAT, ACT kind of results there. Any questions so far? Okay. Very good, very good. All right. So the real question is that why are we talking about percentile here? What we are going to be seeing later on is we're going to be relating the z-score to a percentile. Okay, so we're going to be seeing what the percentile of a particular data item is going to be based on its respective z-score. Okay, so if we can make the process shorter where we can see, hey, what would be the percentile of a particular data item? Well, depending on whatever the mean and standard deviation is, then we can go ahead and figure that out by looking at the relationship between z-score and percentile. Now, we'll be seeing that later on. However, where are we going to use percentile here? Percentile here is we're going to be talking about one more thing here, which is going to take up the majority of the rest of the time here today. And that is going to be talking about box plots. Now, in order for us to, we're going to be talking about how to construct a box plot. That's going to be our goal here for the rest of the day. All right. Now, in order for us to understand box plots, well, we're going to use percentiles here to help ourselves out because we're going to need a few pieces of the puzzle here to start putting it together. Now, so that's what question 5 here you see there on the left hand of the screen is going to talk about. So what are quartiles here? Now, quartiles are based on specific percentiles, as you can see there. So we have a notation here. We have Q1, the first quartile, which is the 25th percentile. And the definition of that is the median of the data set that's to the left of the median. We're going to take a look at that here from a picture point of view. So I know based on how it's written, it looks fairly confusing, but rest assured, we'll see exactly how that looks like. Q2 is the 50th percentile. Q3 is 75th percentile, and Q4 the 100th percentile. Now, as you see already on the screen, the 50th percentile is just straight up the median. All right, just say, hey, this is straight up. So we don't really technically use Q2 because we already have a term for Q2. Smack dab in the middle of the data set is the median. That's where it should be located, is the 50th percentile. So that's exactly what Q2 is. And we don't really use Q4 at all because that's the 100th percentile, i.e. the biggest value in the data set. So, okay, whatever the biggest value is going to be, that's going to be Q4 at the end of the day. All right, so the big two that we want to be looking at here is we're going to be looking at Q1 and Q3. Okay, and we'll come back to this definition here in just a moment. All right, now, this next one. All right, so let's talk about how we can put together a box plot. And we're going to come back to a couple of questions here because I do have a couple questions here. I do need to make these bigger because they're kind of hard to read. We'll discuss exactly what. All right. So what I'm going to do here is I'm going to skip to question number 9, okay, on the handout, which is the last question here. How do we construct a box plot? And I'm going to kind of switch back and forth from question 9 over to these previous 3 questions that I have not acknowledged yet. Okay, so I will be talking about those here, 6, 7, and 8. But for right now, I'm just going to go to question 9 here, and then we're just going to encounter 6, 7, and 8 as we continue to use them. Okay, so how do we construct a box plot? Well, let's get an example up at the very least, and let's see how we can put one together. All right. Well, that's the story. Ah, sorry. Okay. So we're going to do an example here to construct a box plot. Now, in order for us to do so, we're going to go ahead and go back to the well here one more time. We're going to use a stem and leaf plot here once again, okay, as our data set. And I will go ahead and put the stem and the leaves, okay. So we'll put this in numerical order once again, just like we did the last example last time. All right, so let me make some stuff up here. Yeah, I'm just making up numbers, guys, so not doing anything super fancy. Actually, let me change that to 9. Let's change that to 9. Why not? Okay. And come on. Sorry. I can't read my own 9s. My handwriting's pretty terrible, I ain't gonna lie, guys. Alright, let's see. I got 8, 11. Alright, so here's our random example here. with some random numbers in the data set. I've already put these in numerical order, so it should be good to go. Okay, let's go over each step here about how to construct a box plot here using this stem and leaf plot. So let's look at step number 1, and we'll work our way forward. I'll be asking you some questions along, of course, like right now. Step 1, order the data set. We did that already. And find the median. Okay, so we need to find the median here of this particular data set. So can anybody tell me here, what would I do first in order to find the median of this data set? What do I have to do first to find the median of this data set? What do you think, guys? What should I do first in order to find the median of this data set? And type it out in chat. We did order the data there, Chioma. We did order there. We did order the data set, so the data set's already set and ready to go. I did put it in numerical order, so won't disagree with that. What should I do after that? See how many data items are in the data set? Well, I mean, that's not too tough to see. But what do we do with that? Finding Q1 and Q3, that's step number 2, Mike. You're a little bit ahead of the game. I need to find the median first, guys. The median. We talked about it last week. Or last time, really. I think it was last time or last week. All right, Jake says use the equation. Use what equation? Find the position of the median, okay? I like where we're going with that. Where's the position in the median? N plus 1 divided by 2 finds the number in the order. So I'm going to put 2 and 2 together here. Remember, we have to find the position of the median first, okay? So we find the position of the median here. This will equal n plus 1 over 2. You can input the data in the calculator. That's great. I'm sure you could put anything in the calculator and get what you want. But at the end of the day, doing it by hand helps you critically think things through. That's the difference, my friend. It's the difference. You can have a machine tell you, that's great. But people can easily take advantage of that. It's really not too hard. That's why I like to go through things by hand, and then we use the calculator to supplement what we think that the expectation should be. So, all right, so we want to use n plus. So what's the size of the data set? What's the size of the data set here? How many items in the data set? Yeah, so there's 16 numbers here, right? All right, so we have 16 numbers. N is going to be 16, okay? So we have 16 plus 1 divided by 2. All right, good. That's going to be 17 divided by 2, which is going to be the 8.5 position. So the 8.5 position here is where we're going to find the median. Okay, very important here. All right, for what we want to be doing here next. Okay, do you put them order 16? Okay, that's correct. So let's count 8.5 positions here, and we're going to mark that off with a little blue arrow. Actually, we'll mark it with a red arrow, to be honest. All right, let's count 8.5. So 1, 2, 3, 4, 5, 6, 7, 8, 8.5. So 8.5 here will be right here, right where this red arrow is. Okay, so that is where the median is located. All right, now admittingly, we know that there's actually no number actually located in the 8.5 position. So how would I figure out what the median is now? How can I figure out the median? What would be technically the number in the 8.5 position? What would that be? All right, 24 plus 28, and we'll divide that by 2. That's correct. All right, giving you 26, 100% right. All righty, you guys are spot on here. All right, so we'll make a note here that the median here is 26, and we'll come back to this, of course. But the median here is 26, no problem. So far, so good. All right, questions about that? Hopefully that's, again, just a little review from what we discussed before about how we found median, going through the same exact process that we discussed before. This is going to be important. The process here is actually rather important. So, any questions? All right. Let's go to the next step then. Go to step 2. All right. So what is step 2? Well, step 2 is going to be find Q1 and Q3. Now, I do want to discuss about these here a little bit more in particular. Let's try and find Q1 here. Now, in order for us to find Q1, we need to know the definition here. And so let's take a look at how we can find that. So Q1, the basic definition of Q1 is this. This is the median of the data set that is to the left of the median. So we see here on the screen where the red arrow here is where the median would be located. And this is the reason why I drew it out here on screen. I want to look at all the numbers to the left of that arrow, to the left of that median, not including the median, but all the numbers to the left of that arrow, that red arrow you see there on screen. And I want to find the median of that particular data set. And that's what it means to be the median of the data set to the left of the median here. So to kind of highlight what that actually means, let's go ahead and draw it in a... Let's go ahead and draw that in blue. Okay, do it in blue. We're going to circle all the numbers that are to the left of that red arrow. And we'll find the median of all these guys. Okay? So there we go. We have all the numbers there, right? That are all the numbers to the left of that median. Now we're just going to repeat the process here of how we just found the median here. The only difference is, in this case, is that we have fewer numbers than we had from before. Okay? So if we want to, say, find the position of the median, then the position of the median here is going to be, in this case, 1, 2, 3, 4, 5, 6, 7, 8. We're going to have 8 numbers here, plus 1 divided by 2. Again, 8 is the amount of numbers that are to the left of the median. So that's where we came up with the number 8 here in this case. So in reality, we want to look in that circled portion. We want to look at the number that's in the 4.5, the 4.5 position. Okay. Now let's count how many 4.5 positions are. So 1, 2, 3, 4. So where this blue arrow is, that is the 4.5 position, just like so. No problem. So if we want to find Q1 here, we go through the same process we just did in the previous part, where again, we're just going to take the mean of the two numbers around that guy. We're going to take 12 plus 16 divided by 2. And so here for Q1, we're going to get 14. All right, so before we move on to Q3, are there any questions about that? Questions about how we found 14 there? So that's why we needed to find the median here first, guys, is because then we can't, if we don't find the median, then I can't find what Q1 is going to be if I got to do this out by hand. Okay, let's look at Q3 now. Now you guys can help me out with Q3, all right? And I'll show off at least one part of Q3 though. All right, so for Q3 here, again, Q3 represents the 75th percentile here. This is basically on the right side, so meaning to say it's the median of the data set that is to the right of the median. So again, this red arrow here indicates where our median would be located. We're going to circle all the numbers to the right of that particular red arrow. So to the right, so all these guys, I'm going to circle it in purple. Okay, there you go. There's all our numbers there. Again, I'm going to go through the same exact process. Again, finding the position of the median, which is going to be exactly the same, by the way, since we have an equal amount of numbers on both sides. Let me change that a bit. Sorry. There we are. Perfect. All right. So let's count 4.5 positions. So 1, 2, 3, 4. All right. So can anybody tell me what is going to be our mean here? Our median here is located right where this purple arrow is. Can anybody tell me what would be Q3? What would Q3 be here in this case? All right. Okay. So that's correct. 36 is absolutely right. So let's do again. We get 35 plus 37 divided by 2. We get 36. All right. So that takes care of step 2 here. So we did step 1, found the median. Now we've done step 2. We found Q1 and Q3. Any questions about Q1 and Q3 before we move forward? Okay. Hopefully that's not too bad now. Hopefully now it'll make it a bit easier to do. Alrighty. Easy peasy lemon squeezy. Alright. Now, let's take a good look here at step number 3. Alright, step number 3 says to find the IQR. Okay, so IQR here represents the interquartile range, alright? That is step number 3. So what is IQR here? There is a definition for this. Let's scroll up here. So IQR, that's question number 6. Question number 6 says, what is the interquartile range, aka IQR? IQR here is going to be Q3 minus Q1. So we can't proceed to do anything with the box plot until we find this IQR here. It is going to be important here for the next step after that. So again, we take our straight up Q3 and subtract it by Q1. All we got to do is take Q3 here, there's 36. And we're going to subtract it straight up by 14. And so here we're going to get 22. Okay. Seems fair. There it is. Okay. No problem. Now, of course, the question becomes, all right, you found this interquartile range. What are we going to do with it? Now, if you notice, I know seems like a very innocuous step. It's like, hey, why'd you put this as its own step? It's because of how important it actually plays into the role for the rest of the problem. The one thing I like to do, and one thing you'll see me do quite often, is break down steps. And if I feel that one step is important to serve as its own step, then I kind of do it that way. So it's, if you do make a mistake, it's easier for you to see in a separate step. All right, now this basically leads us here to step number 4. Let's take a look at step 4 here. Probably can guess what is already going to happen. All right, so step number 4 here, we'll put that in whatever this color is. So that's a terrible color, I think. Probably pick it around. All right. So step number 4 here is basically find the lower and upper outlier boundaries. Now, there are formulas associated with the lower and upper outlier boundaries, and that is going to be the answer here for question 7 on your handout here. So let's look at question 7. Say, what are the outlier boundaries? Well, I have two things which I kind of paraphrase here. LOB for lower outlier boundary, and UOB for upper outlier boundary. All right, so I take a look here at lower outlier boundary. All right, so lower outlier boundary is Q1 minus 1.5 times the interquartile range that you found from the step before. And the upper outlier boundary is Q3 plus 1.5 times the interquartile range, the IQR there as well, same one that we found from the step before. Now, one thing to keep in mind, guys, is one thing to make sure that you don't fall into is fall for the trap here in terms of solving for these lower outlier boundaries and upper outlier boundaries. The reason is because both of these formulas are different. This is what I'm trying to say here. Take a look at the lower outlier boundary. That's going to be Q1. Okay, it's going to involve Q1, quartile number 1, minus 1.5 times IQR. The upper outlier boundary uses not Q1, but Q3 plus 1.5 times IQR. So what I'm trying to say is that the lower outlier boundary uses Q1, the upper outlier boundary uses Q3. So they use two different quartiles in those formulas. Also, what's different is that the lower outlier boundary uses subtraction, whereas the upper outlier boundary uses addition. Okay, so that's another thing to keep in mind, the two major differences. So one of the common things I see, common traps people fall underneath, is using the same number twice for Q1 and Q3, which is not true. Okay, so be very careful. You are using two different numbers here. The only thing that stays the same is the 1.5 times IQR. The others, they change. Okay. So if I were to do this out here, let's take a look at the lower outlier boundary. I'm going to have to use some of our previous results here. We're going to take Q1 minus 1.5. Again, let's just write out Q1 minus 1.5 times IQR. So Q1 here, we found it to be 14 minus 1.5 times 22. Okay. Does anybody have an answer for this? Again, if you do get a negative number here, that's perfectly fine. So just want the answer for this, though. 1.14 minus 1.5 times 22. Okay, negative 19. All right. Good, good. All right, so here we get minus 19. Okay, great. All right. Now we're going to come back to this number here, so don't worry. We will discuss this number here in just a little bit. But for right now, let's just determine what our boundaries are going to be. Let's look at our upper outlier boundary. Remember, this is Q3 plus 1.5 times IQR. So Q3 here was 36 plus 1.5 times 22. Does anybody have an answer for this? Get here. Got 69. All right. Good stuff. All right. So we have our lower outlier boundary here of minus 19. We have our upper outlier boundary here of 69. All right. Perfect. So this is basically takes care of step number 4. Okay. So what we're going to be using these two numbers for is we're going to be using them as like reference values. Okay, so you'll see how that works here in just a couple of minutes here. But we're going to be using these lower outlier boundary and upper outlier boundary as reference values here in comparison with the data set. So you'll see how that works here a few minutes. Okay, so that's step number 4. Let's talk about step 5. Okay, so step 5 is where, now we've talked about, hey, there's a box plot that has to go with this. I'd be like, okay, that's fair, yes. There should be a box plot that goes with this, so, yeah, how do we do that box plot thing, How does that, how exactly does that work? Well, that's where we're going to start constructing our box plot is right here in step number 5. Okay, so let's read this off here. Step 5, on a number line, draw a vertical line on Q1, the median, and Q3, and then connect them together as a box. So we're going to use our initial amounts that we found here in the first 2 steps and make a nice little box on it and put that over a number line. Okay. Now, let's go back to our, in order to see how this occurs, I'm going to see here. Okay, so 0 to like 55-ish. All right, so I'm going to put a number line here. We technically start at 3, but again, let's just start at 0, and we'll go by 5s. Okay, so we'll put 0 here. We'll put 5. We'll just go by 5s. So something simple. Not a super exact process here since we're doing this out by hand. We have 50, and then we'll put 55 here. We're just putting 55 here because 53 was our. All right, that's fine. All right, so now what we want to do is we're going to draw some vertical lines on Q1, the median, and Q3. So let's take a look here. Now Q1 here was 14. Actually, we could start with the median here technically. Let's start with the median. Median here was 26. So where's 26? 26 is about here-ish. Again, not a super exact science is what I'm promoting here. But 26 is about here. I'll label this as 26. Okay. There we go. That's our median right there. Okay, next is going to be our Q1. Bother me to no end. 6 a bit nicer. All right, so let's look at Q1 here, which was 14. Okay, 14 was Q1, so we're going to go ahead and put a vertical line there at 14. Right about here-ish. And then we're going to put one more vertical line here at 36, which is Q3. So again, kind of fudging it a little bit, but that's okay. Right about here-ish. And now with these 3 numbers in place, we're going to go ahead and connect them in a box, just like so. All right. All right. So there we have at least the box part of the box plot. Okay. Now, we're not quite done just yet, but just to let you know, the box part here. All right, before we move any further, are there any questions? Any questions you guys have? Okay. So, let's talk about what we're going to be doing here next. Okay, so this part here is going to be a little confusing when you hear it at first. I'm going to go over this part here, this next step here, which is going to be, like I said, a little confusing, but we'll go slow, okay? So step 6 is what we're going to do is we're going to draw whiskers on this graph. So we're going to have one line here going out to the left. We'll have, again, we'll have one line here kind of going out to the left. We'll have one line here going out to the right. I'm going to draw some whiskers here. I'll put that in black. So let's talk about each whisker here, the left whisker and the right whisker. Now, in order for us to do this, we're going to use our outlier boundaries that we just talked about here in step 4. This is where they're going to play a role. So for the left whisker, we're going to draw the whisker to the next data item in the data set, which is bigger than or equal to the lower outlier boundary. Let me repeat that. We're going to draw the whisker to the next data item in the data set, so it has to be a data item in the data set that is bigger than or equal to the lower outlier boundary. So if we take a look here, our lower outlier boundary here is minus 19. We found that here in step 4. Now, here's the data set up above. Okay, so now I'm going to put the data set here on screen. Can you tell me what data item in the data set is bigger than or equal to the next data item in the data set that's bigger than or equal to the lower outlier boundary of minus 19? What data item in the data set would be the next one up that is bigger than or equal to minus 19? Okay. I would say Angie says 2. What do other people think? I want to be sure everybody's on the same page here. I need you to be able to see what we're going to be doing here. That's why I'm like being very careful about the wording here, because it can be confusing. So, next data item in the data set, which is bigger than or equal to the lower outlier boundary. All right, so people saying 2, okay? Good. Okay, so 2 here is going to be the correct answer. We have a lower outlier boundary of minus 19. Now we have to pick a data item in the data set that is bigger than or equal to minus 19. Well, the next one up would be 2, and that would be it. So again, one common misconception I want you to get rid of right away is that we're drawing the whisker not to minus 19. Okay, remember, the lower and upper outlier boundaries are just used as reference values, but we are not drawing the whiskers to those reference values. We are drawing the whiskers to data items in the data set. That is very important to note. I'm going to draw this whisker out here to 2, right about here-ish. And then it stops right there at 2. Okay. That's what we have here. That's the left whisker, what we have here. Okay. Now, let's talk about the right whisker and how that works. Now that we have that, how do we draw the right whisker? Well, to draw the right whisker, we're going to draw the whisker to the next data item in the data set that is smaller than or equal to the upper outlier boundary. So things kind of get flipped around a bit. So in this case, the next data item in the data set that is smaller than or equal to, or less than or equal to, whichever way you want to call it, the upper outlier boundary. So our upper outlier boundary, as we can see here on screen, is 69. Now, taking a look at the data set here, what's the next data item in the data set that is less than or equal to, smaller than or equal to, whichever way you want to call it, than the upper outlier boundary of 69? Okay. All right, good, good. So the next data item in the data set that is less than or equal to, smaller than or equal to, the upper outlier boundary of 69 is the number, the data item of 53. That is correct. So we're going to draw our right whisker here all the way out to 53. Good, good. Nice, nice. All right. So we'll put 53 right here. Now, we are finally finished with our box plot, just like so. That's it. That's going to be finishing off our box plot here. However, I do want to make a couple of notes here. So there are certain other things that we have to do. So we're not completely finished yet, but this is the picture of the box plot as it should be based on the steps. However, what can happen here in certain data sets, and I've added this note down here, is that sometimes you may get data items that are outside of your outlier boundaries. So, for example, any data items in the data set that are less than the lower outlier boundary or larger than the upper outlier boundary can be marked with an X. And the reason why we call it an outlier boundary is because those are what those numbers are called that are basically served to be way outside the boundary are outliers. Again, data items that are either too large or too small. Essentially, at the end of the day, the way to kind of visualize this is to say, all right, if I had a data item of like 87, now 87 is much bigger than 69, so what I would do is, all the way out to the right here, I would mark this with an X for the number 87, okay, just like so. And then this would be how I would represent that on a particular box plot. Again, this is more reflective of extreme values that we get in the data set. Okay, so extreme values usually fall in the category of having X's, representing each one of those data items. Okay, so just to let you know how what would work, this is exactly how it works here in this circumstance. Okay. Now, there is one more thing that we need to do here today. Let's talk about that. We need to talk about one thing. So one more thing we'll need to talk about here is the last question here that we haven't acknowledged, and that's still on this handout here. And that is this question here, number 8, which just says, what is a 5-number summary? Now, a 5-number summary is a very simple, short, and sweet thing that you can use in order to, again, do exactly as it sounds, summarize a particular data set using the 5 most major numbers. And of course, it uses the numbers that we have just found here throughout this process. So if we talk about a 5-number summary here, it's fairly simple. If you take a look there, it's, again, super easy. Let me just put this down. Okay, so basically we go with the lowest number first. So the lowest number in the data set here, again, low represents the lowest number in the data set, which is 2. So we'll put 2 here first. Then we'll put Q1. Q1 we found from the second step. Q1 was 14. Then we take the median here. The median here was 26. Again, we found that here in step number 1. We did Q3. Q3 here we found it also in step 2, which was 36. And then we take the largest number here in the data set, which in this case here was 53. And that basically is our 5-number summary for these guys. Now, I know you have the same exact numbers here from step 5 in terms of your box plot as you do for your 5-number summary. What I do want to point out is that this doesn't happen all the time because of extreme values that could happen. Whereas you could have like X's out in the middle of nowhere, because those values are really, really high. Well, then that has to be reflected in your 5-number summary. So it's not always going to be these same 5 numbers you see here. Remember to look at each individual case carefully. All right. So that is how we can construct a box plot and put it together. Any questions about that? Any questions at all? Okay. Now, yeah, these are definitely recorded. If you click on the videos tab on my channel, you can see previously recorded classes. Or you can go to my YouTube channel, whichever one you wanted to go. I have I won't have it up this class uploaded because I have to wait 24 hours or longer, but um, I do have a YouTube channel, so that's where I kind of archive all my old footage. All right, so there is something that I do need to talk about here specifically. All right, now this is the end of chapter 3. All right, now it's very important we do talk about this because it's the end of chapter 3. That means that we've covered all the material here for the first exam, which covers chapters 1 through 3. Okay, so what I'm going to do here is I do need to make a due date here for all the homework and the subsequent test, okay, for chapters 1 through 3. So the due date here for everything for these particular sections and chapters 1 through 3 specifically, I'll put that here. Due date for all homework, and if I can spell, and the chapter test is date here. Right. Okay. So it's going to be the 23rd. Okay. So the 23rd is when all the homework and the tests are due, and the test is due. All right. Is the 23rd. So that's 2 weeks from today. Okay. So 2 weeks from today. That should give you plenty of time of which to finish anything and everything. If you already kept pace, then you should be in great shape. Again, I highly recommend. Actually, I don't even recommend. Would like you to try the practice test because the practice test is the real test, just with the extra added additions of like the resources and stuff. Get to know how to use. I get to know what kind of questions will be on the exam. Again, you get multiple tries on the actual exam, but remember, you do get bonus points if you try the practice exam and do pretty good on it. And again, that will help you prepare for the real test. For the real test, you get, again, 10 hours and 5 tries to get the best score possible. All right. Um, so one thing I will tell you in regards to the test here, something that you do need to know is the test here in terms of its options. Okay, I set it up in a way where it has a save for later option. So what that means is that you go in order of the questions, right? So you can't really skip around. And so when you do those order of the questions again, you do those in that order. And then basically, let's say you're feeling super tired or something like that, and you know what, you want to take a rest for the night. Well, you can go ahead and stop the test right there, and then you can, get some rest, come back the next day and resume the test. You're definitely allowed to do that. So you don't have to necessarily do it all in one shot. However, however, the caveat is that you cannot go back and do previous questions you have already attempted. So that's the caveat. All right. So you got to be careful there. Do the questions again. If you say, hey, I want to stop at question 10, you stop at question 10 and then you resume. said, okay, I tried question 10, resume from question 11 moving forward. And then that's how you basically do a save for later kind of option there. All right. All that stuff, though, again, all that stuff here will be due in 2 Thursdays from today. So 2 weeks from today at the end of the day. So I'll be changing some due dates around on my math lab. But that is when the homework and the tests will be due. All right. For chapters 1 through 3 specifically. However many questions are going to be on the practice test. I don't remember how many questions I put, but it don't. But yeah, it's not intended to take you too long. So yeah, we're still meeting on that day. Yep, 100%, me and G. Just because a test is due that day doesn't mean we're not meeting. We are still meeting on that Thursday. I'm just making the test due on that date, just so that way it meets along with class days. But you guys have plenty of time of which to finish. Literally a month to finish. So. And 3 chapters I don't feel should be a long time of which to finish. So I think it should be very doable, especially I've given you a warning of 2 weeks as opposed to 1. So I think that's very, very doable. And yes, one more thing, because I've given plenty of time here, again, please do not ask for an extension, right? So please do not ask for an extension. I'm just going to say that outright right now. I've given you plenty of time of which to finish. And it should be, again, you should be able to get through this material here within the next 2 weeks for 3 chapters. All right. Yep. You saw that coming? Yes. Oh, I saw that coming from a mile away, too. I ain't going to lie. Like, I get the emails, I need an extension. Be like, I've given you enough time. You had a month to finish. All right, that's plenty of time in which to do things. So you guys gotta get on it and get it done. That's what I'll say to that. Any questions? Any other questions you guys have? Oh, all right. So remember, let me go to the big board here once again. So remember that all the tests can be found underneath the quizzes and tests. Okay, so if you click on quizzes and tests, you'll get a list of all the tests. Okay, again, try the practice test here, then you can try the real test after that. And then you have the list of all the homework assignments. Like I said, I'll be changing these due dates to the 23rd to reflect. Actually, I'll just do that now. I'll just do that right now. I'll do it in front of you, so that way you can see what I'm doing. Yeah, it's really not too hard. It's actually pretty easy. But I always like full transparency, so I'm like, okay, I'll just do it in front of you. It's not that big of. Let's see if this works though. The system is so picky, man. I ain't gonna lie. Come on. There we go. All right, let's change all the chapter 1 through 3 stuff. Always full transparency, number 1. All right. It's not a lot of sections, guys. Honestly, it's not a lot of sections. So if I can, oh yeah. All right, apply that. I gotta do that for the test down here. Right? Let's apply it to that too. That'd be great. Wonderful. All right. All right. And that should work out just fine. There we go. All right. So now the due dates have been changed. All right. You see it just happened right in front of your face. All right. And you should be pretty decent to go. Let me check one thing here really quick. I was asked how many questions was on the test. I know I didn't put too many here for this test, so I'm gonna check. Let me check that here. There are 30 questions. 30 questions on this test. I don't think it'll take you 10 hours to finish 30 questions, but there are 30 questions on the test. So, if you wanted to know, it's not supposed to be super bad. You know, it's not supposed to be super long. But 30 questions is pretty reasonable. So, and if you try the practice test, you'll know exactly what questions are going to appear on the actual test because they are the exact questions outside of the numbers. So, there's no surprises, guys. No surprises whatsoever. No surprises at all. All right. Very good. Okay, so that will take care of it for today, everybody. I want to thank you all very much for coming on. I had your stream once again. Everyone, please enjoy your weekend. I hope you get a nice chance to rest and relax. Make sure you catch up with that homework assignment. Again, all the homework from chapters 1 to 3 you should get on that ASAP. And then once you get that finished, get started on the test ASAP. You can get the best score possible because that's what I want for you and that's what you want for yourself. So let's do it together. All right? Thank you very much, everybody. Have yourself a wonderful weekend. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Have a great one, everyone. Take care of yourselves and have a nice, lovely, bubbly, jubbly weekend. All right. We'll see you later. Have we'll see you later, everybody. Take care. All right. Bye. Bye, everybody.